Welcome to training Program 10.1b on the IBM Selectric Typewriter. This program is a continuation of training Program 10.1a, and it covers the operational theory and the adjustments of the cycle clutch or print clutch. Of the various clutches used in the IBM Selectric Typewriter, the cycle clutch is by far the clutch which is used most often. It has to operate whenever the machine prints. Think of it as a print clutch. First, we will point out and locate all of the mechanisms which are powered or driven by the cycle clutch. Then we will dismantle the cycle clutch for a close look at the components. And finally, we shall reassemble it, performing the adjustments as we go. In the previous training program, we saw that the torque provided by the motor, which we call positive power, is made available from the center of the power frame all the way to the indicated right side of the typewriter. We examined and then labeled the various clutches according to their function in the typewriter. By now, it should be obvious to you that this shaft is really the drive, or the power shaft, of the IBM Selectric Typewriter, in spite of the fact that it is called the operational shaft. This is a cycle clutch assembly. Its primary function is to select and to print the characters, but it has some additional functions, such as ribbon lift, ribbon feed, activating the escapement, and a few more. The important thing to keep in mind is that very many mechanisms are affected by the cycle clutch adjustments. The cycle clutch, or print clutch, consists of a spring friction clutch, which operates in exactly the same manner as the shift clutch we studied earlier. This means that the clutch spring is kept distended or opened when the clutch is not engaged, and that the spring will collapse or shrink its diameter, using its own tension as soon as the spring is released or unlatched. When the cycle clutch is engaged, it transmits torque to the cycle shaft, located immediately to the left of the clutch. As a result, when the cycle shaft rotates, it does so in the direction top to the front. The job of the indicated cams, located on the cycle shaft, is to carry out the character selection. The cam on the right is called the -5 cam, and the two cams on the left, which are exactly alike and have only one cam follower, are called the +5 cams, although this name does not describe their function completely. Notice that all of these cams are double-lobed, which means that for each revolution of the cycle shaft, we get two cam follower oscillations. At the end of the cycle shaft, on the left outside of the power frame, we get a single cam follower, which is the one that is connected to the cycle shaft, and for that matter, the cycle clutch. At this point, be sure to familiarize yourself with the cam followers for the cams mounted on the cycle shaft. Take as much time as you need, whenever you need it. Make it a point to become thoroughly acquainted with all of the pointed-out parts of the machine. This is one of the few instances in life where the closest possible familiarity will only aid you, so don't hesitate to pause often. As mentioned, if we follow the cycle shaft toward the left, we find that it extends toward the outside of the power frame, where it drives the cycle shaft gear. If the gear train on your machine is covered, remove the cover at this point. Here, the yellow pencil indicates the cycle shaft gear, which drives the gear train. Gear train is the name given to this aggregation of gears. As we trace the propagation of the driving torque coming from the cycle shaft gear, we find that it branches off and ends at two shafts, which are indicated by the red pencils. On the lower right, we find a gear which is mounted onto a shaft called the filter shaft. Furthermore, we find that since the cycle shaft gear rotates top to the front of the typewriter, or clockwise, and since the total number of gears in the chain is 3, an odd number, the filter shaft gear, and for that matter the filter shaft, must also rotate clockwise or top to the front. As we examine the chain which leads to the upper gear mounted on the print shaft, we find that it has an even number of gears, so the direction of rotation for the print shaft is reversed, namely top to the rear or counterclockwise. Notice also that the upper gear, or print shaft gear, is only half the size, half the diameter, or half the number of teeth of the other gears. This means that for every revolution of the cycle shaft gear, the print shaft gear, and for that matter the print shaft, will have to perform a complete revolution. Conversely, for every 180 degrees of rotation of the cycle shaft, the print shaft has to rotate 360 degrees. This shaft is called the filter shaft, in spite of the fact that in the region indicated by the red pencil, it is primarily a very wide double-lobed cam. The filter shaft extends all the way toward the right side of the machine yellow pencil, where on later machines, there are at least 4 more cams. The wide double-lobed cam portion of the filter shaft, indicated by the red pencil, is the portion of the shaft which gave it its name. Whenever we print a character with the IBM Selectric Typewriter, there are a total of 7 different selector latches that tilt, or rotate, or print the position which holds the character chosen by the typist. One of the 7 latches is used to select the correct printing velocity for each character. It turns out that for 5 of these 6 latches, the machine uses negative logic in order to come up with the correct combination of selector latches. This means that the machine picks out the latches which it does not want to use in a particular operation, rather than picking the latches which it does need in order to select the correct character. In short, the machine filters out the latches which it does not want to use. This filtering job is carried out by the filter shaft, or rather, by the wide double-lobed cam on the filter shaft. As we track down the other cams of the filter shaft, we find that from left to right, the next cam is the spacebar inhibit cam. It cuts out the spacebar mechanism during printing operations. This cam can also be viewed from the top rear of the machine in the operational shaft cavity. From this position, you can obtain a much better view of the cam follower. The third cam on the filter shaft is the printing escapement cam, indicated here by the blue pencil. The cam follower for this cam holds the already familiar escapement link, yellow pencil. Thanks to the printing escapement cam, we space the carrier 1 step toward the right every time we have finished printing a character. The only exceptions to this rule are the so-called dead keys used for accents and markings, but they are not used in the English language. The fourth cam on the filter shaft, this one already located outside the power frame, is the velocity control mechanism restoring cam. In order to prevent certain characters with small printing surfaces, such as periods and commas, from cutting through the paper, the velocity control mechanism, when released, regulates the momentum with which the element hits the paper during printing. The velocity control mechanism, restoring cam, has the job of reloading the spring tension, which operates the velocity control mechanism after each time it has been used. The fifth and last cam on the filter shaft, indicated by the blue pencil, is the shift mechanism inhibitor cam. During all printing operations, the type element is firmly held in position by a mechanism called the detenting mechanism. This is to ensure the best possible alignment of characters. The shift mechanism is nothing more than an extension of the rotate mechanism, as we will come to fully understand in package number 4-5. If during a printing operation, in which the element is détented, we were to attempt a shift operation, somewhere in the chain of parts leading through the element, some more delicate part would have to give or possibly sustain major damage. By inhibiting the shift mechanism during printing, we prevent this sort of mishap from occurring. The yellow pencil indicates the cam follower, which will prevent the shift ratchet from allowing the clutch engagement during printing operations. Green pencil, on your machine, you may find an earlier level mechanism performing the same function. At this point, take time to acquaint yourself with and review all of the cams on the filter shaft as best you can. The cycle clutch will have to power all of these cams during each and every printing operation. Inside the carrier and around the print shaft, there is a tube which supports 3 cams. This tube is called the print sleeve. The print sleeve is keyed to the groove in the print shaft so that it has to turn whenever the print shaft turns. On the majority of machines, we have 3 cam clusters, rather than simply cams, mounted onto the print sleeve. The leftmost cam, yellow pencil, is the ribbon lift cam, or cam cluster. Regardless of which kind of ribbon, or even the correcting tape, the lifting of ribbons is accomplished by the cam or cam cluster on the left side of the print sleeve. The cam cluster located in the middle contains the detent control cam and the ribbon feed cam. The cam cluster on the right, indicated by the green pencil, is the print cam cluster, or simply the print cam. On typewriters equipped with a correcting tape mechanism, we find an additional cam lobe on the right side of the sleeve, which performs the function of feeding the correcting tape whenever it has been used. At this point, hand cycle the machine, and again familiarize yourself as best you can with the various cams on the print sleeve. Trace as many of the cam functions as you can make out, and keep in mind that all of these functions are driven by the torque, or positive power, delivered by the cycle clutch, which you're about to study. As mentioned before, the cam cluster located in the center of the sleeve contains the detent and the ribbon feed cams. The camming surface used for detenting is indicated by the yellow pencil. Notice that it is located on the side of the cam and that it exerts left-to-right pressure onto the sleeve. The green pencil indicates the surface, which constitutes the ribbon feed cam. We shall now disassemble the cycle clutch for the purpose of getting to know the nomenclature and the theory of operation of the clutch. But before we remove any of the gears, examine the engagement of these gears. There should hardly be any play between the teeth of the gears. This condition is referred to as minimum backlash. Let us first remove the C-clip of the upper idler gear shown here. In reality, we want to remove the upper idler gear only in order to get access to the mounting screws for the lower idler gear. We need to remove the upper idler because the nylon teeth on the upper gear would very likely sustain damage if we attempted to remove the lower idler gear without first removing the upper one. Depending on the model or the level of the machine which you are using for this course, you may not have the C-clip. You would then have to loosen the stud, which holds the upper idler in its position. Now remove the lower idler gear by extracting the indicated screws. Be sure to use a screwdriver that is wide enough to prevent the screw heads from becoming marred or otherwise damaged. On the 11-inch machine, all we have to do is remove the nut on the bolt which holds the lower idler gear in position. The bolt, which doubles as a shaft, will then also come loose. We have now cleared the way for the removal of the cycle shaft bearing plate. But before we go at the screws which hold the plate in its position, let us examine what else is held in position by the same screws. Notice the part indicated by the blue pencil. This part is one of the clamps which holds down the dust shields for the space under the carrier. While its position is not very critical, it nevertheless is adjustable and must firmly hold the dust shield in place after we finish the reassembly procedure. The screw indicated by the red pencil holds only the bearing plate, so it can be removed without any further consideration. The story is quite different for the screw indicated by the green pencil. On the outside of the power frame, this screw holds a protective shield over the gear train. For safety purposes, it is very important to reinstall this shield on the 13-inch and on the 15-inch machines. Again, you have one less part to worry about on the 11-inch machines. The same screw which holds the safety shield also holds the check pawl for the cycle clutch. Just as with the ratchet clutches and the shift clutch, the cycle clutch needs a clutch latch and a clutch check pawl in order to hold the clutch spring under tension. The yellow pencil indicates the point of engagement between the cycle shaft, or cam, and the check pawl on level 2 machines. This is how the same function is carried out on level 1 machines. The check pawl ratchet, as well as the level 2 check pawl and cam system, offers 4 positions in which the check pawl can prevent the cycle shaft from turning top to the rear. We pointed out earlier that the cams on the cycle shaft are double-lobed. This means that the cycle shaft only performs 1/2 of 1 revolution each time it is used for the printing of a character, and that there are 2 home, or rest, positions for the cycle clutch. In both of these positions, we will need the check pawl in order to hold the cycle clutch spring open or disengaged. This takes care of 2 of the check pawl ratchet teeth. The other 2 are used for 1/2 cycle position markings of the cycle shaft. It is important to mention that the term cycle shaft is actually a misnomer if we understand cycle to mean revolution. On the IBM Selectric Typewriter, the cycle shaft is said to cycle every time it performs a printing operation. For every printing operation, however, the cycle shaft only performs 1/2 of 1 revolution. If we then consider that the check pawl positions add up to a total of 4 positions, we know that they are only 1/4 of 1 revolution apart, and not half a revolution. Be sure to remember that on the Selectric, a cycle shaft cycle stands for only 1/2 of 1 revolution of the cycle shaft. We could also say that 1 character printing operation represents 1 cycle for the cycle shaft, and that 1 cycle for the cycle shaft is in reality only 1/2 of one revolution of the cycle shaft. To remove the check pawl, let us first disengage the check pawl spring, as shown here. At this point, you can either remove the spring from the machine altogether, or simply get the spring out of your immediate working area by trapping it on the outside of the power frame, indicated by the yellow pencil. Now we can finally remove the check pawl mounting screw. This check pawl mounting screw is far more important than meets the eye. For one thing, we note that it is screwed into the power frame, which really makes it part of the power frame. Since the right end of the screw holds the check pawl, and since the check pawl is used as a reference for the home position of the cycle shaft, we deduce that the rest positions of all of the cams and shafts, which we studied earlier, use the check pawl, and this screw as the ultimate reference point. You will hear many times that adjustments of the cycle clutch, of the print shaft, of the filter shaft, as well as the individual cams on the filter shaft, must be made with the cycle shaft against, or in, its check pawl position or home position. And all the while, the check pawl is held in its position by the check pawl mounting screw. In order to remove the cycle shaft, we must relieve the pressure the cycle shaft receives from the +5 cam follower or the positive latch bail. We begin by removing the indicated +5 bail, restoring spring, as shown. The yellow pencil indicates the lower anchor spot for the tilt and rotate bail, restoring spring, or the positive latch bail, restoring spring. The green pencil indicates 1 out of 5 different selector latches, which are also holding the tilt and rotate bail upwards against the +5 cams on the cycle shaft. We must remove the selector latches as well if we want to be successful at lowering the cam follower. We can accomplish this by simply filtering out all of the latches located under the pump. The positive latch bail. Now we have to widen the diameter of the cycle clutch spring so that it becomes possible to pull the cycle clutch spring off the driving arbor, just as we did with the shift spring. With the use of a screwdriver, the yellow pencil, we hold the cycle clutch sleeve top to the rear by pressing down on one of the steps of the cycle clutch sleeve. With our left hand, we rotate the cycle shaft gear top to the front, and at the same time pull the shaft towards the left without forcing anything. Should we detect any obstruction or impediment, we immediately stop pulling and investigate the cause of it. There is only one character on the keyboard which requires that combination, namely, the Z. The first obstruction along the way is likely to be the -5 latch link, indicated by the red pencil, which is usually in the way of the right +5 cam. While it is possible to use a screwdriver and press down a bit on the link, it is also very possible to break the link on account of the forcing. We recommend a better way. In order to be able to depress the Z, make sure that the on-off switch is in its on position. First, tilt the machine up so that it is possible to work under it. Using a spring hook, we simply unhook the -5 link from the -5 latch interposer at the point indicated by the red pencil. While you're at it, you might also remove the next link, yellow pencil. This link is the +1 latch link. The links should now fall down freely, so that it becomes very easy to remove the cycle shaft from the power frame. And then rotate the filter shaft top to the front by 1 revolution. Now we get to see the cycle clutch driving arbor. The indicated grooves in it are there for lubrication purposes. It is very important that the clutch be properly lubricated, because even when the cycle clutch spring is opened, there are points at which the inner surface of the clutch spring still rubs against the driving arbor while the machine is idling. Proper lubrication will keep the wear to a minimum. Once you have depressed the Z, rotate the filter shaft again top to the front. Here are the same grooves on the shift clutch arbor. It is quite frequent that one has to replace the hub pulley assembly because of cracks in the nylon hub. To remove the pulley, it is necessary to also remove the cycle clutch latch and then the rotate bell crank. Since we have not yet shown you how to adjust the rotate mechanism, of which the rotate bell crank is a part, we will omit that job at this point. For the sake of exercise, you might now remove the motor belt and then reinstall it again. It takes doing it once in order to know that it is a very simple matter. The green pencil indicates the slot on the cycle clutch sleeve, which holds the right end of the cycle clutch spring, yellow pencil. Whenever we want to get at the right end of the cycle clutch spring, from now on we can go to the cycle clutch sleeve. The outside steps on the cycle clutch sleeve offer a much greater surface for the physical contact between the right end of the cycle clutch spring and the cycle clutch latch. We will see the cycle clutch latch in the upcoming slides. The blue pencil indicates the left end of the cycle clutch spring. The left end of the cycle clutch spring is fastened to the cycle shaft by the clamp and the screw indicated by the red pencil. This cycle clutch clamp is responsible for holding 4 different adjustments of the cycle clutch in their respective positions. As a matter of fact, in a strict sense, all of the adjustments dealing directly with the cycle clutch, not the controls for the cycle clutch, are held in position by this clamp. The nylon cam directly under the red pencil, or under the cycle clutch clamp, is called the cycle clutch latch restoring cam. In addition to restoring the cycle clutch latch, this cam also provides an overthrow stop for the cycle shaft. Let us quickly tell you now what the 4 adjustments of the cycle clutch are. First, the lateral position of the cycle clutch spring. Second, the angular position of the cycle clutch spring. Third, the lateral position of the cycle clutch latch restoring cam or the nylon cam. And fourth, the angular position of the cycle clutch latch restoring cam. And watch the positive latch bail fall down under its own weight. With this done, you have cleared the way for the removal of the cycle shaft. This is the cycle clutch latch. It does exactly the same job as those parts which IBM calls clutch release arms on the other clutches. Let us see whether you can accurately describe the function of the clutch latch or the clutch release arms without any further assistance from us. Take a moment and try. The latch, in the case of the operational cam clutches, the shift clutch, and the cycle clutch, is that part which gets placed into the path of the rotating sleeve, ratchet, or disc. Once it is properly positioned or restored, it is able to stop the rotation of the sleeve, disc, or ratchet. The first job of the sleeve, disc, or ratchet is that of providing a means to hold one end of the clutch spring. The second job of every sleeve, disc, or ratchet is that of providing an overthrow stop for the cam, or cams, that are being disengaged by the action of the clutch latch. IBM uses the expression to release the clutch in order to describe the action of engaging the clutch. Be sure to become aware of the fact that these 2 expressions mean exactly the same thing. It does not matter how many times you need to review the statement just made, you must do it until you understand it. We cannot possibly overemphasize this fact. The objective of this training package is not that of renaming a bunch of parts, the names of which have originally been chosen by the manufacturer. The objective is that of making you understand and capable of repairing these clutches when they need repairs. This is only possible when you know what you are doing. Whether you call a certain part a latch at one point, a ratchet at another, a clutch disc or flange in a third place, is in a sense immaterial. It is expected of any serious office machine repairman that he should demand of himself the ability to see right through this instructed jargon of latches, release arms, or on the other hand discs, sleeves, and ratchets, and to recognize the true essence or functions of the part or the mechanism which he is studying or repairing. We recommend that you review the explanation of the function of a clutch latch or release arm until you can state it yourself. Before we move on, let us mention that the position of the cycle clutch latch can be adjusted vertically and horizontally. Vertically, it should be adjusted so that it holds the surface of the step in the cycle clutch sleeve perfectly parallel to the bottom of the typewriter whenever the cycle clutch latch is engaged with it. This condition is easily obtained by measuring the distance from the top of the pivot pin for the latch to the top of the filter shaft. This distance should be 39.1 millimeters or 3.9 centimeters. We will see in just a few more slides that the number 3 scribe line of the hooverometer is used to measure this distance. The cycle clutch latch is held in its restored front to rear, or horizontal, position by the part called the cycle clutch latch keeper, indicated by the red pencil. The exact position of the clutch latch in relation to the clutch sleeve can be adjusted by the front to rear positioning of the keeper. The position of the keeper is changeable by loosening the screws indicated by the blue pencil. What then is the correct horizontal position of the cycle clutch latch? The horizontal position of the clutch latch should be such that it engages with the clutch sleeve by the thickness of the metal of which the clutch latch is made. This condition is indicated here by the red pencil. Since this condition is not readily visible on a machine which is fully assembled, When one uses a sharp tool such as a spring hook and slides it over the indicated junction point between the sleeve and the latch, it becomes easy to recognize whether there is a step or not between the two. If you are able to detect any step, the adjustment is not set correctly. Be sure to locate the indicated junction point in your machine and then run a spring hook over it in order to check the adjustment. As we mentioned earlier, we will cover the vertical positioning of the cycle clutch latch during the reassembly process. Here is how we release the cycle clutch, or how we engage the cycle clutch. Whenever an operator depresses a character key, the interposer, which is the part above the bail indicated by the red pencil, bears down on the indicated bail, and the bail in turn disengages the pawl which is engaged with the cycle clutch latch keeper. The part above the bail, or behind the red pencil in this picture, is the center lug of the character interposer. Every character has one of these character interposers, and they all have a different combination of lugs or lug positions. The center lug, however, is common to all of them. The center lug of the character interposer is responsible for the tapping of the positive power needed in order to drive the printing mechanism, or, more specifically, to engage the cycle clutch. The other lugs on the interposers are used in order to perform the selection of the character to be printed. Whenever the cycle clutch is to be engaged, the cycle clutch latch is pulled out from under the step of the cycle clutch sleeve by the action of this spring. The selection of the character to be printed is accomplished through the tilting and the rotating of the type element. The characters on the element can be divided into characters belonging to the hemisphere containing the capital characters and the hemisphere containing the small characters. Notice that in this photograph, the exact center of the element, marked by a manufacturing seam line, constitutes the separation line between the two hemispheres. The mechanism which makes the selection between the two is the shift mechanism. In reality, then, the shift mechanism is only an extension of the rotate mechanism. When we are printing a character, we cannot rotate the element at the same time in an effort to select capital letters or small letters, because during the printing, the element is firmly détented, or locked. Since the selection for capital or small letters is commanded by the operator, it is necessary to provide a reciprocal locking mechanism. We do not want to print a character for as long as we are rotating the element from one hemisphere to another, and we do not want to rotate the element from one hemisphere to another for as long as we are printing. You will recall that we became acquainted with the shift inhibit cam at the rightmost tip of the filter shaft when we studied all the cams which are driven by the cycle clutch. The mechanism, which is partially shown here, is responsible for the inhibiting of the characters during shift operations. The position of the lug indicated by the green pencil is controlled by the shift cam detent. Whenever the shift cam is rotating, this lug gets into the way of the cycle clutch latch link indicated by the red pencil. Even when the operator goes through the motion of engaging the cycle clutch during a shift operation, the cycle clutch cannot become engaged until the shift operation has been completed. Be sure to examine this mechanism carefully and trace the lug position to the shift cam follower or shift cam detent. It should be clear to you that the shift cam has to be in one of its détented positions in order for it to become possible to release the cycle clutch. As we mentioned, this is the cycle clutch restoring cam. The engagement of the cycle clutch is accomplished by allowing the clutch latch to move out of the way of the sleeve. The disengagement of the cycle clutch is performed by first positioning, or placing, the latch back into the path of the rotating sleeve, and then stopping the sleeve. The pencil points at one of the two lobes responsible for the restoring of the cycle clutch latch. Notice that the cycle clutch latch restoring cam is held in place by the metal clamp. Can you remember the 4 adjustments which are controlled by this clamp? Take a moment to think it through, perhaps write your answer down, and then check yourself against the answer. The jobs of the metal clamp of the cycle clutch are: first, to hold the lateral position of the cycle clutch spring; second, to hold the angular position of the cycle clutch spring; third, to hold the lateral position of the cycle clutch latch restoring cam, the nylon cam; and fourth, to hold the angular position of the cycle clutch latch restoring cam. Learn this one way or the other. Keep reviewing until you've got it. This frame shows the cycle clutch latch restoring cam follower and the cycle clutch latch. The stud indicated by the green pencil can be adjusted up or down in order to bring it closer to or further away from the cam when the cycle clutch latch is latched, or in its rest position against the keeper. When the cycle clutch latch restoring stud rests on top of the indicated cam, it should hold the cycle clutch latch link towards the rear of the machine, in a position which is illustrated in the next slide. When the cycle clutch latch restoring cam uses the highest point of its lobes, the distance between the latch pawl and the keeper should be approximately 1/2 of 1 millimeter. Check your typewriter for this clearance. Now you should simply take some time out in order to play with these parts. When the cycle shaft is assembled and out of the machine, it is much easier to examine and study its operation in detail, so we recommend that you do it now. Let us see whether you can answer a few questions on the cycle clutch operation. Who performs the job which in this picture is being carried out by the yellow rod? If you said that it is the job of the cycle clutch latch, very good. Can you remember and describe the adjustments for the cycle clutch latch? This is a most important question, and you should really try hard to answer it on your own. Take a moment to think of the details. Here is the answer. 1 is the vertical position of the cycle clutch latch. It is performed with the use of the hooverometer on its number 3 scribe line. The second adjustment is the cycle clutch latch bite adjustment. You must ascertain that the clutch latch engages with the cycle clutch sleeve by the thickness of the metal, which makes up the latch. The first adjustment constitutes the vertical position adjustment of the cycle clutch latch, and the second adjustment constitutes the horizontal adjustment of the cycle clutch latch. If you answered this question correctly, we extend our congratulations. Let's have one final question. Which part of the typewriter performs the job, which in this picture is being carried out by the left hand? If you said it's the part placed into the path of the rotating sleeve, ratchet, or disc to stop it, you've got it. Once restored, the latch stops the sleeve, and remember, IBM's phrase to release the clutch actually means to engage it. If you said the latch should engage the clutch sleeve by the thickness of its own metal, exactly right. Run a spring hook over the junction between sleeve and latch. If you feel any step, the adjustment is off. If you listed the lateral and angular positions of the cycle clutch spring, plus the lateral and angular positions of the nylon latch restoring cam, congratulations, that's all 4. That one clamp holds every direct cycle clutch adjustment in place. If you said the cycle clutch latch, very good. It's the part that drops into the path of the sleeve to stop it and disengage the clutch. If you named the vertical position, set with the hooverometer on its number 3 scribe line, and the bite adjustment, engagement by the thickness of the latch metal, you earned our congratulations. That's the vertical and the horizontal adjustment of the latch. If you said the cycle clutch check pawl, exactly right. It holds the shaft against turning top to the rear, trapping the spring tension until the next print cycle. We now cover the final portion of the discussion of positive power in the IBM Selectric Typewriter, specifically the cycle clutch or the print clutch. Your answer to the last question should have been the cycle clutch check pawl, which is mounted at the point indicated by the green pointer. Let us now engage in a brief overview of the operation of a clutch. Just as important as the understanding of the function of the cycle clutch latch is the understanding of how a clutch spring is first distended, stretched, or opened, and then how it is held distended, stretched, or opened. You should treat the following information just as meticulously as you treated the information when discussing the function of the clutch latch. Once the sleeve, the ratchet, or the disc of a clutch has stopped against the latch, the right end, or simply one end, of the clutch spring can no longer continue to rotate with the cam or the shaft. The cam or the shaft, however, will continue to rotate because of the momentum it has acquired while the clutch was closed or engaged. As the cam or the shaft continues to rotate because of its momentum or inertia, the clutch spring is opened or stretched. All the while, the cam or the shaft keeps rotating top to the front of the machine. After a certain amount of this rotation, the check pawl falls behind the tooth of the check pawl ratchet on the left side of the cycle shaft. The same occurs with the other clutches, where after the disc or sleeve stops against the latch or the release arm, the cam continues to rotate until the check pawl engages with the check ring. Once this has happened, the spring tension has already become trapped because the cam or the shaft can no longer rotate top to the rear. The check pawl would prevent it. At this point in time, however, the shaft or cam has not yet quit rotating top to the front of the machine. Somebody has to actually stop it from rotating too far. After every printing operation, the cycle shaft is stopped from rotating too far by the step indicated here by the red pencil. This step on the side of the cycle clutch latch restoring cam is referred to by the name of cycle clutch overthrow stop. In reality, however, it takes more than this step in order to stop the cycle shaft. When the cycle clutch sleeve is stopped by the cycle clutch latch, the latch obviously also stops the step in the sleeve indicated by the green pencil. The continued rotation of the cycle shaft will eventually cause the step indicated by the red pencil to stop against the step indicated by the green pencil. So the cycle clutch latch has to stop first the cycle clutch sleeve, and then, indirectly, the whole cycle shaft. In the case of the ratchet clutches, the overthrow stop is simply the outside corner of the opening in the clutch disc. But the overthrow stop for the printing mechanism is adjustable. After the overthrow stop has interrupted the top-to-the-front rotation of the shaft or the cam, the clutch spring starts acting on the shaft or the cam, trying to turn it back, top to the rear, so as to allow the spring to collapse again. This is going to be possible only for as long as the check pawl allows it. As said before, the spring tension is then literally trapped in the clutch, with the latch holding it on one side and the check pawl on the other. The motor runs idle until the operator comes along and releases the latch again. The spring then collapses, closing or engaging the clutch, and the whole thing starts all over again. When the clutch is fully assembled, the clearance between the overthrow stop on the cycle clutch restoring cam, red pencil, and the step on the cycle clutch sleeve, green pencil, when the cycle shaft is resting against the check pawl, should be approximately 1/4 of a millimeter. This is achieved by the angular positioning of the cycle clutch latch restoring cam, using, of course, the cycle clutch latch as the fixed point. It is most important to mention here that the cycle clutch overthrow stop does not only stop the cycle shaft at the end of the printing operation. It stops the whole printing mechanism, which comprises the cycle shaft, the filter shaft, and the print shaft. We repeat, it is a fallacy to think of the cycle clutch as the clutch driving the cycle shaft only. The cycle clutch is in reality our printing clutch, or print clutch, and all mechanisms having to do with printing are driven by it. Think of the cycle clutch as the printing clutch, and it will help you understand the mechanism. On early level, or level 1, machines, the overthrow stop looks like this. The difference between the two styles is minor. The cycle clutch latch restoring cam, indicated by the blue pencil, is held by screws, red pencil, which screw into the clutch clamp. On level 1 machines, the restoring cam is simply positioned outside the clutch clamp. While this may make the clutch easier to adjust and separate its steps, this mechanism works just as well as the later model. Let us now take the clutch apart by loosening the cycle clutch clamp, as shown here. If you are working with a level 1 machine, notice that the left end of the cycle clutch spring, indicated by the red pencil, is positioned into the slot indicated by the blue pencil. Needless to say, this is where it goes when you reassemble the mechanism. If your cycle shaft is from a recent serial number machine, the -5 cam will be marked with a small scribe line, like the one indicated here by the green pencil. This scribe line is used as a reference mark for the preliminary mounting or assembling of the cycle clutch spring. The lug indicated by the yellow pencil is to be aligned with this mark. Notice that the lug indicated by the yellow pencil is substantially longer than the lug indicated by the red pencil. In the event that your cycle shaft cam does not have this scribe mark, simply line up the long lug of the cycle clutch spring with one of the lowest spots of the -5 cam, and you will be just as well off. The lug indicated by the red pencil fits into the window on the sleeve. Under the green pencil, we have the cycle shaft arbor, or the driven arbor of the cycle clutch. After we have preliminarily positioned our cycle clutch spring, we also position, still on a preliminary basis, our cycle clutch restoring cam and our cycle clutch clamp. The slot of the cycle clutch restoring cam, red pencil, should be lined up with the slot on the cycle clutch clamp, yellow pencil. And the clamp should be lined up with the hole for the high lobe of the -5 cam. It is immaterial which one of the -5 lobes you use, they are the same. At this point, make a deliberate effort to rotate the spring only, while the whole clutch is assembled and out of the machine. Of course, first you have to loosen the clutch clamp. Then, to turn the spring top to the rear, apply the turning force to the right end of the spring until the left end of the spring slips top to the rear by the distance we want. To rotate the spring top to the front, we go to the left side of the clutch spring, and there apply top to the front turning force to the left lug of the clutch spring. As we apply the force, we watch the right end of the spring. Once it changes its position, we know the spring has slipped on the arbor. We can summarize this by saying that if we want to change the lateral position of the clutch spring, we apply opposite torque on both ends of the spring. We need 2 hands or 2 tools for that operation. When we only want to change the angular position of the clutch spring, however, we apply the torque in the direction desired for the change onto the spring end, which tends to open the spring or expand its diameter. Torque applied to the other side just plain will not work, because the tendency will be to tighten the spring rather than allow it to slip and change its angular position. We conclude that to change the angular position of the clutch spring, we need only one tool, applying torque to the end of the spring, which tends to open it. Be sure to review this explanation carefully. You will need it when it comes to adjusting the angular position of the cycle clutch spring. While the cycle shaft is still out of the power frame, you should also take time to examine the cam followers for the cams located on the cycle shaft. The red and the green pencils point at the rollers which are part of the tilt and rotate bail, also known as the +5 rotate bail or the positive latch bail. When the cycle shaft is properly mounted and we wish to use the bail, we must check whether both rollers are actually making contact with the bail at the same time. You might also take some time to check the pivot point for the +5 rotate bail. You will find that the right side of the pivot shaft can be adjusted so as to establish physical contact between the +5 cams on both sides of the cam follower. Before you attempt to reinstall the cycle shaft, make sure that the -5 cam follower is lowered into its latched position. If it is not latched, it will interfere with your cycle clutch or cycle shaft installation. Now proceed with the reinstallation of your cycle shaft. Remember that the straight edge of the cycle shaft bearing plate should be positioned vertically in the machine. Here we begin the sequence of adjustments of the clutch, which drives the printing mechanism, and which IBM calls the cycle clutch. After the cycle shaft bearing plate has been properly secured by its screws, we must check the end play of the cycle shaft. The purpose of this check is to reduce the clearance between the driving arbor and the driven arbor of the cycle clutch to a minimum, so as to prevent the inadvertent drawing of a clutch spring coil into the space between the arbors. To enable us to perform this check, it is most important that we allow space between the cycle shaft gear and the cycle shaft bearing plate, as shown by the red pencil. The very simple rule for the installation of the cycle clutch gear is that it should be laterally lined up with the lower idler gear, so as to produce maximum engagement between the teeth of the 2 gears. On new style machines, the end play of the cycle shaft is reduced to a minimum by the lateral position of the indicated collar. On older machines, we have to install shims between the bearing plate and the check Pawl ratchet. The end play should not be much more than 1/10 of 1 millimeter. You will find this adjustment depicted in frame number 1 of your adjustment manual. Loosen all of the gears which have set screws. They are the print shaft gear, the cycle clutch gear, and the filter shaft gear. Then adjust the position of the lower idler gear so that it provides maximum engagement between the cycle clutch gear, the lower idler, and the filter shaft gear. This is done to reduce the backlash of the gears to a minimum. After you have fastened the lower idler gear, spin it once or twice to make sure that you have not created any binds for the gear train. Repeat the procedure for the upper idler gear. Remember, minimum backlash, no binds. Now spin the whole gear train. It should feel snug and a bit draggy, but it should not have one bit of a bind. Now set up your hooverometer so that the lower edge of the slide coincides with the number 3 scribe line. Be sure that the slide of your hooverometer is mounted in the same way as the hooverometer being shown here. We are going to use the hooverometer to adjust the vertical position of the cycle clutch latch. Make sure that the filter shaft is rotated so that the groove does not interfere with the measurement being performed here. The distance from the pivot point of the cycle clutch latch to the upper edge of the print shaft should be such that the hooverometer slide, set on the number 3 scribe line, just touches the upper edge of the print shaft. If the position of your cycle clutch latch happens not to meet the required condition, these are the bracket supporting screws, which, when loosened, will allow you to change the vertical position of the cycle clutch latch. The vertical position of the cycle clutch latch can be off in 2 ways, causing 2 different kinds of problems. When the position of the cycle clutch latch is too high, at the point indicated by the red pencil, the horizontal surface, or upper edge, of the cycle clutch latch is not flush with the flat surface of the step on the cycle clutch sleeve. In other words, the 2 surfaces form an angle which opens toward the front of the machine. The possible malfunction resulting from this condition is extra cycles or uncalled for cycles of the cycle clutch. The cycle clutch latch may at times be literally cammed out of the way of the cycle clutch sleeve. At the moment when the latch has to take the impact of whatever is left of the momentum of the cycle shaft, the machine will then type an uncalled for underscore or an uncalled for hyphen. This condition is called flicking. When the position of the cycle clutch latch is too low, the effect is the opposite. The step of the cycle clutch sleeve now develops so good a bite onto the upper surface of the cycle clutch latch that the latch becomes sluggish in getting out of the way of the sleeve when it is supposed to. This condition must also be avoided, particularly since it affects the touch of the machine, and that might make the operator quite unhappy. Now tighten the cycle shaft gear, making sure that it is lined up with the lower idler gear, as demonstrated. After you have tightened the cycle shaft gear, turn the cycle shaft into one of its 2 check pawl positions. This means the check pawl should be engaged with the step of the ratchet, or on newer machines, with the edge of the opening in the left +5 cam, as shown here, with the cycle shaft rotated top to the rear as far as possible. Now rotate the filter shaft so that the distance between the leading edge of the cam and the step of a depressed character interposer is approximately equal to 1/4 of 1 millimeter. Then allow for just a very small amount of end play for the filter shaft, and tighten the filter shaft gear. Now line up the print shaft groove with the dimple indicated by the red pencil, then allow for a very small amount of end play for the print shaft, and tighten the print shaft gear set screws. The very small amount of end play for the print shaft and for the filter shaft should be just enough to make sure that no bind develops in the system because of your timing of the gears. This timing of the print shaft gear is only the preliminary timing of the print shaft. We will study the fine timing of this gear when we study the type element detenting mechanism. With these steps out of the way, we have made the preliminary adjustments of the printing mechanism. Only after these steps have been carried out can we begin to adjust the cycle clutch proper. To review this segment, go back over the material beginning with the cycle shaft end play check. Once again, these steps are the preliminary adjustments of the cycle clutch. Only after they have been carried out can you begin to adjust the cycle clutch proper. Now reconnect the latch links. On the new machines, the clevises should be adjusted so that there is no possible pulling of the links without also pulling the selector latch. At the same time, be sure not to prevent the selector latch from fully engaging with the positive latch bail. On the older machines, allow for a maximum of 1/4 millimeter overlap of the latch going beyond the rear surface of the positive latch bail. More about this will be covered in training program number 10.3 on the IBM Selectric Typewriter. With this, we have come to the first of our cycle clutch adjustments, namely the lateral position of the cycle clutch spring. Notice the gap or space, which exists between the right edge of the cycle clutch spring and the shoulder of the pulley hub. This clearance should be reduced to 1/4 of 1 millimeter. When the clearance is not there, the pulley hub might interfere with the operation of the cycle clutch spring. Any excess gap, on the other hand, will cut down on the number of coils of the cycle clutch spring, which can be engaged with the driving arbor. The end result would be a reduced life for the cycle clutch spring. To make it possible to position the spring sideways, it is necessary to lift the pulley hub. You first loosen the clamp, and then open, or expand, the diameter of the spring. The diameter of the spring can only be expanded if we hold both ends of the spring and build up pressure between them. After rotating the cycle shaft into the convenient position shown here, we use 2 screwdrivers and place the spring sideways into the desired position. Keep an eye on the scribe mark in the left end of the spring. After you position the spring laterally, you should have the left lug lined up approximately with the scribe mark. As mentioned, this is only a preliminary setting for the angular position of the spring anyway. We now have to position the collar and the cycle clutch latch restoring cam, because in our next adjustment, we must start out with the clutch spring held in its position, no matter how far off we are. We must therefore learn how to set the preliminary position of the restoring cam and the collar. First, we position the opening in the clutch latch restoring cam and the collar around the left end of the clutch spring green pointer, so that we are slightly off-center, with the larger portion of the opening toward the rear of the machine. Then, we position the collar in relation to the nylon cam so that we have equal portions of the nylon cam showing, as indicated by the yellow and the blue pencils. Do not yet tighten the collar. So far, our efforts take care of the preliminary setting of the angular position of the restoring cam and the collar. Now let us go to the lateral positioning of the two. Before we tighten the collar, we should always position the cycle clutch restoring cam sideways so as to allow for a bit of lateral play for the cycle clutch sleeve at the point indicated by the green pencil. It is very important not to cause any binds for the cycle clutch sleeve, since this could hamper the movement of the spring when it tries to collapse. Now we tighten the clamp. Do that now, and get ready for a miniature brainstorming session. After the lateral adjustment of the cycle clutch spring comes cycle clutch adjustment number 2. Can you remember what it is? Your answer should have been, the second adjustment of the cycle clutch is the angular position of the cycle clutch spring. The angular position of the cycle clutch spring is very important to this mechanism, since it determines by how much the clutch spring is held open. First, let us learn how we determine whether our adjustment is correct or not. We have to introduce a method which allows us to measure or gauge the stress, the distortion, or the amount of opening which we cause the clutch spring to undergo. Consider this. When we cycle a character, the motor will drive the cycle shaft until the exact point at which the clutch disengages. In other words, until the right end of the spring, or the step of the sleeve, stops against the cycle clutch latch and disengages the clutch. When we use the hand cycle wheel instead of the motor, and hand cycle the operational shaft and the pulley slowly, the cycle shaft will also turn slowly, and the momentum developed by this slow turning will be negligible or almost nil. If, in addition to this, we use a character which places a load onto the cycle shaft during the last portion of the rotation of the shaft, we know for sure that the cycle shaft cannot develop any momentum at all. That is accomplished by choosing the letter M. To perform the second adjustment of the cycle clutch, we depress the letter M and then slowly hand cycle the operation until the cycle shaft is no longer driven by the cycle clutch. Another way of saying the same thing is to hand cycle a letter M until the cycle clutch begins to slip. Then, we go to the print shaft bearing and make a mark on it. We made ours on the spring which holds the bearing. We then take a good look at the point of the print shaft gear which coincides with the mark. In our example, it is the low portion of the dwell between 2 teeth of the print shaft gear. We must now place this information in the back of our mind. Let us see whether you can answer this. Where did the print shaft stop when the cycle clutch began to slip? All we have to do is look at it. When the print shaft stopped, the cycle clutch began to slip at the point where the lowest point of the space between the teeth, immediately above the tooth indicated by the red pencil, is aligned sideways with the mark which we made on our print shaft bearing. Now we must check how far this is from the check Pawl position. In other words, we shall continue to turn the cycle shaft and find out how much further we have to turn it before the check pawl falls into its rest position. But we cannot keep our eyes on the gear and the check pawl at the same time. So we simply place our left finger on the pawl in order to feel when the pawl falls into its position. With our right hand, we depress the letter M once more. And then, very, very slowly, we turn the hand cycle wheel while keeping our eye on the print shaft gear and our finger on the check pawl. In our example, the check pawl fell into place when the indicated gear tooth, the one with the black mark on it, was aligned with the mark on the bearing. This amounts to just slightly more than 1/2 tooth of rotation for the print shaft. The manufacturer's specifications call for anywhere between 1/2 and 1 full tooth of rotation before the check pawl falls into its position. We know, therefore, that our adjustment is correct. The most interesting question at this point is, what should we do in the event that our adjustment is set incorrectly? Simple. First of all, there are only 2 possibilities. 1, that we disengaged our cycle clutch too early. We determine this by finding that the print shaft gear had to turn more than 1 full tooth before the check pawl fell into its position. Can you tell us what we should do to correct the problem? Your answer should have been, rotate the cycle clutch spring top to the rear so that it can drive the cycle shaft further before the cycle clutch sleeve meets the cycle clutch latch and disengages the cycle clutch enough that it must begin to slip. The second possibility is that we get less than 1/2 tooth of rotation for the print shaft gear before the check pawl falls into its position. Now the cycle clutch is driving the cycle shaft too far. The corrective measure here is to rotate the cycle clutch spring top toward the front to enable the cycle clutch sleeve to stop against the cycle clutch latch earlier. All the while, we must make sure that the cycle clutch latch restoring cam, or the overthrow stop, is kept rotated top to the rear far enough so as not to interfere with our clutch spring adjustments. Given the right conditions, the overthrow stop cam can cause jamming of the cycle clutch when it does not allow sufficient rotation for the cycle clutch sleeve. Whenever this happens, we have to manually disengage the cycle clutch latch and correct the position of the overthrow stop before we can continue with the adjustments of our cycle clutch spring. Now think back for a moment. Let us assume that this operation had been performed by the motor, and that we had printed our letter M. The cycle shaft would, of course, have rotated all the way into its check pawl position, bringing the left end of the cycle clutch spring with it. The right end of the spring, however, was stopped earlier by the cycle clutch latch. The free spin of the cycle shaft caused the spring to expand. How large was this free spin? If it was more than 1 tooth of rotation, the clutch spring ended up being opened too much. If the free spin was less than 1/2 of 1 tooth, the clutch spring was not opened enough. We are quite confident, to say the least, that it would not hurt you to go through this information again before continuing. Make sure that you stay with it and repeat it until you understand it, and until you can honestly say that you know it. A good starting point for a review is the lateral position of the cycle clutch spring, covered a few moments ago. Next comes the third adjustment of the cycle clutch. The third adjustment is the lateral position of the cycle clutch latch restoring cam. We take care of that whenever we clamp down the cycle clutch spring. Just always make sure that whenever you tighten the clamp, the cycle clutch sleeve has enough side play so as not to allow any binds to develop. What about the fourth and final adjustment of the cycle clutch? Can you remember what it was? The fourth and last adjustment step of the cycle clutch adjustments is the angular position of the cycle clutch latch restoring cam, or the overthrow stop adjustment for the cycle clutch. There is one extremely important point to remember when making this fourth adjustment. Be sure to let the clutch spring collapse before you loosen the clutch clamp. Remember that a spring must be held at both ends for it to be possible to build up any tension in it. The moment we lose hold of one of the ends, the spring will collapse. Should we ever make the mistake of loosening the cycle clutch clamp when the right end of the spring is being held open by the cycle clutch latch and the left end is being held by the check pawl, we will immediately lose the angular position of the cycle clutch spring, and we would have to start again from the beginning with our 4 adjustments of the cycle clutch. If, however, you make it a habit to always and only work on the cycle clutch adjustments when the cycle shaft is rotated into the position shown here, you will always have let go of the right end of the cycle clutch spring. And when the spring is collapsed around the arbor, it does not slip and change its position unless you first expand its diameter. It therefore becomes very simple to open the clamp and adjust the angular position and/or the lateral position of the cycle clutch restoring cam without disturbing the position of the spring. After we get done with step number 4, we should check steps number 2 and 3 once again, just in case they might need some correcting. The angular position of the cycle clutch restoring cam or the cycle clutch overthrow stop should be adjusted so that the amount of play between the maximum forward position and the maximum rearward position of the cycle shaft at the indicated point is approximately 1/4 of 1 millimeter. At this point, perform this final adjustment of the cycle clutch. Can you still make a list of the preliminary adjustments of the printing mechanism for the cycle clutch? It should contain these items: cycle clutch latch height adjustment with the hooverometer, cycle shaft end play, gear backlash elimination, filter shaft timing, and print shaft timing. You might even have included the cycle clutch latch restoring adjustments. These preliminary adjustments place our machine into a condition which allows us to cycle the printing mechanism. As a result, we can turn our attention to the cycle clutch or the print clutch. Can you make a list of the adjustments of the cycle clutch? 1. Lateral position of the cycle clutch spring. 2. Angular position of the cycle clutch spring. 3. Lateral position of the cycle clutch restoring cam. 4. Angular position of the restoring cam, the overthrow adjustment. Upon conclusion of the cycle clutch overthrow adjustment, we make it a point to recheck adjustment number 2, the angular position of the cycle clutch spring, for the 1/2 to 1/2 of rotation required before the latching stop. This is the timing of the check pawl. Make whatever corrections are needed on the cycle clutch of your typewriter. If you said the angular position of the cycle clutch spring, well done. That's the one that determines how far the clutch spring is held open. If you said rotate the cycle clutch spring top to the rear, you nailed it. That lets the spring drive the cycle shaft further before the sleeve meets the latch and the clutch begins to slip. If you said the angular position of the cycle clutch latch restoring cam, the overthrow stop adjustment, that's the one. Just remember to let the spring collapse before you ever loosen the clamp, or you'll lose your spring position and start all 4 adjustments over. If your list had the latch height with the hooverometer, cycle shaft end play, gear backlash elimination, and the filter shaft and print shaft timing, you're right on the money. These are what put the machine in condition to cycle the printing mechanism at all. If you said lateral and angular position of the clutch spring, then lateral and angular position of the restoring cam, the overthrow adjustment, perfect. And after that 4th step, always recheck the angular spring position for the 1/2 to 1/2 of rotation before the latching stop. Now rotate the cycle shaft top to the front as far as it will go, and then check the position of the filter shaft. The interposers should all be able to come down without touching the cam of the filter shaft. You may refine the position or the timing of the filter shaft at this point if it needs it. As your last step in this program, be sure to reset all of the keylever restoring springs by placing a screwdriver as shown and then forcing it straight up. Congratulations on finishing this first of our series of 5 training segments on the IBM Selectric Typewriter. You should review this material often, particularly if you do not work on these machines all the time. You should now continue your studies with package number 10-2. Thank you for your attention.